Hi guys, David here with another science update. So today I'm looking at this article that says, can we really extract ancient DNA from dinosaurs? And I thought this article was interesting and worth sharing because, among other things, what it does is it actually goes through the process of showing how we extract ancient DNA. And this has a number of interesting implications, of course, not the least of which is that we've all seen Jurassic Park, presumably, so this idea that we could extract DNA from dinosaurs and perhaps resurrect the T-Rex and other things like that, which is obviously a pretty bad idea if you've watched the movies, but it's still a really interesting premise. But the idea of working with ancient DNA doesn't just stop or find its worth in the idea of resurrecting ancient species. There's also a lot of insights that scientists can make into things like the direction of evolution and other questions of scientific import. So the article says, what is ancient DNA? So ancient DNA can be isolated from the bones or tissue of a museum specimen or other types of preserved remains. The article gets into the question of why do we need to learn about ancient DNA? It provides a very accurate snapshot of genetic diversity in a particular point in time at a particular location, which is useful in terms of understanding how genes have changed with regard to different environments, for instance. It also provides data that fossils can't give us, such as family relations. In fossils, minerals replace the once living part of the body like bone and tissue, so DNA isn't preserved. So this is the part that I particularly wanted to share with you because I was not aware of how this works, but you might find it interesting. So this is actually how they extract ancient DNA. So what they do is they take a small sample of bone or tissue, preferably if they have it. Then they break open the cells by grinding or squashing. They have to remove the fats from the sample with some kind of, they say, special detergent, so presumably some sort of soap or surfactant molecule. They then separate the DNA from the proteins using an enzyme that degrades the protein, but does not degrade the DNA. And then they pull the DNA out of the solution using precipitation. Precipitation is basically if you have a solution of something. So what they have here is a solution of degraded proteins and DNA. It's where you put it into a solvent, into another liquid that will dissolve all of the stuff that you don't want anymore. And then the stuff that you want to collect will precipitate, which is basically it will fall to the bottom or come out of solution. It will go from liquid phase to a solid phase. After that, they centrifuge the sample so that all of this undissolved DNA that just crashed out of solution will basically collect at the bottom of the tube. And then they say clean the DNA. I imagine that means that they're probably washing it with other solvents, but I'm not sure. And then they amplify the DNA using PCR. And PCR is a way to take a small amount of DNA and turn it into a large amount of DNA of the same sequence. And basically, PCR makes use of an enzyme called DNA polymerase to synthesize new strands of DNA complementary to the original strand. And basically the idea is that you start with a DNA strand and you heat it to basically cause the two halves of the DNA to split from each other temporarily. And then in the presence of a solution of DNA nucleotides, which are the building blocks for DNA, they put it through another heating cycle, which allows the DNA polymerase enzyme to basically double or replicate both halves of the DNA. And then basically they put it through multiple cycles, heating cycles, heat and cool, which allows this splitting and then growth and then reassembly. And that's how you amplify DNA. And it's really an amazing invention. It was invented in the 80s, and the basic bottom line of it is that you can take some DNA, put it into solution with some other compounds, and then put it into like a little box that will basically heat it and cool it over multiple cycles. And you can take a tiny segment or a tiny sample of DNA and make as much of it as you want. And that's really a key discovery when it comes to a lot of medical technology, but even when it comes to this kind of ability to work with ancient DNA is we can take a small sample and replicate it hugely. So unfortunately, it's hard to get the complete genome of like an old species. So they say low quantity, degraded, and fragmented DNA and contamination are the 4 issues that we have with ancient DNA. Over time, the DNA of a dead body breaks down into smaller and smaller units until it disappears altogether. The older a sample is, the more degraded the DNA is, unless something like extreme cold slows down the process. So they answer the question of what is the oldest ancient DNA. They say DNA survives a maximum of 1 to 1.5 million years, so forget about dinosaurs. To date, the oldest DNA found and extracted was from mammoth specimen that was potentially up to 1.6 million years old. The DNA was better preserved than other ancient mammoth specimens because the northeastern Siberian permafrost stopped it from degrading quickly. The extreme cold slowed down the process of degradation. So that means, I think that means there's still a small chance that you could potentially find a dinosaur specimen that had intact DNA if it was really cold. So maybe if we eventually got to where we could do more paleontology expeditions in Antarctica, and I know that there are some paleontology expeditions in Antarctica, but it's really hard, obviously, to dig holes and things like that there. Maybe somewhere in Antarctica we'll find a T-Rex or something like that that has a deep frozen tissue specimen. That would be cool. I don't know if that's possible or not. That's probably pushing it. But, they said in this article, 1.5 million years is really the maximum. And that's just because they haven't found any specimens other than this 1.6 million year old mammoth that are much older than that. So if they find a 30 million year old specimen, then I think they're going to start saying DNA survives a maximum of 1 to 30 million years. I found this other article by the Smithsonian, and they said these are the extinct animals we can and should resurrect. So obviously, again, we've all seen Jurassic Park, so it's probably a bad idea to try to resurrect a T-Rex. And then, but they asked this author of How to Clone a Mammoth: The Science of De-Extinction, Beth Shapiro, who's an expert in ancient DNA. They asked her, what extinct animal would you most like to bring back to life? She said, oh, this is nice. She says the best choice would be an animal that could not only inspire people to be interested in science and technology, but that also would have a net positive impact on the environment. In my mind, the mammoth is a great choice for both of these reasons. I mean, the mammoth is a cool animal. It's basically like a big hairy elephant. What's not to like? She said, what about the most dangerous? So obviously, as I said, like the T-Rex would probably be the most dangerous animal to resurrect. But this would be the most dangerous animal that we actually could resurrect potentially, which has enough DNA that we've been able to extract. She said, I would be most afraid of the giant short-faced bear, which lived during the last glacial maximum until about 11,000 years ago. When the largest of these bears stood on his hind legs, he would have been nearly 12 feet tall. And by comparison, a polar bear is about 8 feet tall, a full-grown male polar bear, when it stands on its hind legs. So we're talking half again the size of a polar bear. And then here's a good question is, how long before de-extinction is a reality? She says the answer depends on what you're willing to accept as de-extinction. If you mean a pigeon born with some passenger pigeon traits, so passenger pigeons I guess are extinct, or an elephant born with mammoth-like traits, it could happen within a few years to a decade. So in other words, we might be able to take an elephant and imbue it with mammoth-like traits, but probably making a 100% mammoth with all mammoth genes and behaviors, that will never happen. So that's too bad. So I think this is a really interesting topic, and I do hope that maybe in the coming years we start to see more updates about some of these de-extinction efforts, and just in general, maybe we can learn more in the future about how it is that this DNA extraction takes place and what they can do with this ancient DNA. So thanks so much for watching. This has been another Science Update. If you liked the video, please go ahead and like and subscribe, and I hope you'll join me again soon. Bye.